Right. Is it recording? Hi. Hello, Professor. I know I'm kind of doing this a little bit late, but Hawaii took much more time than I expected, but you know what they say, better late than never. And just to kick it off, I found a little joke. What do baby parabolas drink? Quadratic formula. But that's actually what we're talking about here, because I'm doing lesson 3.2, quadratic equation functions and zeros. Quadratic equations is in an area, it's set up as ax squared plus bx plus c. And a, b, and c have to be real numbers. If you look at this example here, I have 6x squared plus x equals 15. For us to be able to get the equation, we have to have all the numbers on one side. So I subtract by 15 by both sides, got rid of that, and I got 6x squared plus x minus 15. And according to this rule right here, the a is going to be the number 6. So a is 6. Then of course, in front of that x is a 1, so the 1 is going to be b. The negative 15 is going to be c. Go ahead and zoom out a little. And that's how you get the equation. Now I'm going to show you how the different ways to solve for it. So here we have equation solving principles. The first one, the principles of zero products. If a, b equals 0, then a or b is equal to 0. So a equals 0 or b equals to 0. The principle of square root is if x squared equals to a number, then it's going to end up x squared plus minus square root of that number. Now as we come to here, on solving the equation, I have two examples. The first one I have 5x squared minus 65 equals 0, because we ain't always going to have c with us. No, b. Sometimes we're not going to have one of those numbers. So we have to figure out a different way besides using the quadratic equation. So here, I have to get my number on the opposite side. So I do plus 65. Plus 65 to get on the opposite side of the equal sign. And that makes it 5x squared equals to 65. Then I will have to divide 5 by both sides. Once I do that, I get x squared equals to 13. And if you follow this arrow up here, of course to this rule that we just used from the square root principle, if it's x squared equals to a number, then that's going to equal x equals plus minus square root of the number. So back here we have x squared equals 13. We're going to move it up. Now we have x squared plus minus square root of 13, which just ends up being x equals square root of 13, comma, negative square root of 13. Alright, example number 2 is we're using the quadratic formula. The quadratic formula is very popular in college algebra, which is x equals negative b plus minus square root b squared minus 4ac divided by 2a. So we have our numbers here. We have a, b, and c. We write down our quadratic formula and we just put in our numbers. So negative 8 goes to b, 2 goes to a, c goes to negative 3. And then these right here, these two negatives make it to a positive, so it'll make positive 8. Negative 8 squared in parentheses make it to 64 positive. You always make sure you put the parentheses on the outside before you're square rooting it, or it'll get another negative number. And then negative 4 times 2 times negative 3 is plus 24. Once we got here, 64 plus 24 is 88. Now that we can't do much anything else, we could lower it. We could lower it because these both have a divisible. We break this up. We break this up first, and the common that we see is these both are divisible by 2. So when we break these up, when one is positive, one's negative, according to the square root rule, and when we simplify it, it's 4 plus square root of 22 divided by 2, and 4 minus square root of 22 divided by 2. And last, I'm going to be talking about with lesson 3.2 is the discriminant. in the formula, negative b plus minus square root b squared minus 4ac divided by 2. The b squared minus 4ac is the discriminant number. That's the discriminant. When we plug in the numbers and we get a number, that's going to be the discriminant. When it's positive, there'll be two different real number solutions. When we pull it out of the number and we add it up and it equals to 0, there's only be one number solution. And when we put all the numbers in and we combine it, add it up, all that, and we get a negative, that means there's two different imaginary numbers. Go ahead and zoom out a little bit. Well, that's my presentation on lesson 3.2. Hope you enjoyed it.